All right, today we're going to be going over notes number 19, which is more quadratic word problems using the calculator to help us to solve our problem. First problem says that suppose you want to build a pen for your dog and you have 500 feet of fencing material. Okay, what is the maximum area that can be enclosed? Well, we know that when we have the area, it's area of a triangle, it's simply the length times the width, okay? I'm going to call the width x, all right? And we know this guy over here is x. So the total fencing we had was 500, all right? And we're going to subtract 2x, right? And we have two of these sides, so this one is half of that, and the other side is 500 minus 2x divided by 2. We can go ahead and simplify this, and we will get 250 minus x. All right, now that we have that information, we're going to set up our function. Our function, simply the area as a function of x is equal to the length times the width, which is x times 250 minus x. I'm writing with my mouse, so it might not be the neatest thing in the world. All right. What we're going to do is, first thing, we're going to use our calculator and turn it on. And first thing we should do is reset our calculator. So we're going to go to second, mem 712 to reset our calculator. We're going to go ahead and enter our equation in the y equals, and what we have is x times 250 minus x. Close the parentheses. We're going to hit graph, and when we do, nothing shows up. The reason nothing shows up is we have not yet adjusted our window. So for our minimum value, we're going to put in 0. For our maximum value, we're going to put in 250. And then the scale, we'll make our scale, let's say 50, so we'll have 5 tick marks on our screen. And for our y minimum, we're going to set our y minimum of 0. The maximum value that we're going to have to enter, you're going to have to play around with this till you get a number where everything shows up in your quadratic equation. I've already done that, and I'm just going to tell you that it's 20,000. Because it's such a large number, we don't want to have 20,000 tick marks. We're going to say that our scale is at 1,000. If I hit graph, hey, we got the entire parabola in there. That's good. All right. Go ahead. We're always going to record the information that we have. And we said that x was equal to 0 to 250. All right. So we write that down. On our y value, the range of our y value on our calculator, we went from 0 to 20,000. So I'm going to be lazy and put 20K just so save myself trying to write with the mouse. All right. We have our graph, and what it looks like is the parabola, and we're going to recreate that on our on our graph here, but I guess first we need to figure out what the maximum value of that parabola is. In order to do that, as y'all might remember, we go to second, trace, and we want to know the maximum because it's a downward pointing parabola. It asks us first for the left bound, so we're going to move our cursor over to the left a little bit, hit enter. We then move our cursor to the right of where we think the maximum is. We hit enter. We hit enter again for our guess. And it tells us that our maximum value of y is 15,625. That is our vertex. Our vertex has the coordinates 125 and 15,625. So I'm going to write that down here. Our vertex is at 125x, and our y value is 15,625. 15,625. Okay. Oh, that was a little too. All right. There we go. All right. To graph our equation, we're going to go from 0. Well, I guess we need to label everything. We had 5,000, 10,000, 15,000, and on the x-axis, we had 50, 100, 150, 250. All right. When we draw our parabola, it's going to go up, and it goes just beyond 15,000, and it comes down here. So we've got a graph. This, the y-axis, I'm going to go ahead and fill everything in. You need to label your graph completely. This is the length of the fencing, okay? And the units of, I guess if I could spell, length of our fencing. Y'all can imagine that. Length of our fencing is in feet. All right. And then our area is in square units. And once again, I'm going to be a little bit lazy. I'm going to write down that we have 15K, 10K, and 5K. And this is our area. And the units of area are square feet. So we're going to write down feet squared. Okay, so we've got our graph, we've got everything figured out. We need to figure out our domain. Our domain goes from 0 to 250. It's inclusive, so we use square brackets. So we have 0 to 50. All right. Our range went from 0 inclusive 0 to 15,625. That's the number we calculated on, used on our calculator. I'm going to write it down here. Okay. So we're getting there. We're getting close. All right. We need to figure out our y-intercept. Well, our y-intercept starts at the origin, so that one was easy. We write down 0, 0. Now we need to figure out our x-intercept. Well, it crossed at 250, so we simply have 0, 250. So far this has been pretty easy. Hardest part was figuring out the formula and how to write our dimensions for our rectangle. It says, what is the maximum area that can be enclosed? Okay, the maximum area come across, that was the maximum height. All right, and we know from our vertex and we know from our range that the maximum area we can enclose is 15,625. 15,625. Please write the units down. That is important. Square feet. All right. Then the next one says, what are the dimensions which will yield the maximum area? Well, we have our formula. Area is equal to length times width. Length times width. We know that our maximum area is 15,625. All right. And how do we get that? That would be a square. So we have 125 times W times W. Right. And we divide 15,000 by 125, and we get that W is equal to 125. I'm going to go ahead and write that down. 125. So our answer is 125 feet by 125 feet. We've now solved problem 1. Okay, we're going to move on now and work on problem number 2. Okay, problem number 2 is different a little bit. Now that we have a building and I represented it here with the axis, I've redrawn the drawing. We still have 500 feet of fence. We know that our width is equal to x, and we know that our other width is equal to x, and our length is equal to 500 minus 2x. Okay? Same scenario, except now it's 500 minus 2x, which we're not going to have to divide by 2. All right? Are we going to be able to include a larger area, do you think, since we only have to worry about fencing on one side? That's basically what the question is asking us. So we're going to set up our calculator window, and to set up our calculator window, our x isn't going to change. It's now between 0 and, well, it might have changed. I can't remember what we put last time. I'm going to put 300. And for our y value, that's the one that is going to increase. Well, last time we had used 20,000, so I'm going to go ahead and double it and say 40,000. So I'm going to write down 40K. Probably can't get twice as much area, but we're just going to do that for the purpose of setting our window. All right. So for this case, the function that we're going to use is the area as a function of x is equal to the length times the width. So we have x times 500 minus 2x. 500 minus 2x. We are going to enter that into our calculator, and we're going to change our window. So with our calculator on, there was our old graph. We're not changing that much. It's just a variation of the problem, so I'm not going to reset the calculator. I'm going to go to the window, and our x min is still 0, and our x max, I wrote down 300, so we're going to write down 300. This time is just so I can show y'all. Our scale is still 50. For the minimum, I said we were going to go with 0, and we're just guessing here, but I doubled it to 40,000. Okay, 40,000. We're going to use the same scale as of 1,000. We're going to hit graph. Okay. Did I already enter the equation? No, I didn't. Our equation is simply x times 500 minus x. So I changed the equation there. I now hit graph, and oh, we went up and we're not within our scale. What happened? Our x max we should be fine there, and our min 40,000. Did I enter the equation wrong? Y is equal to 500. Oh, that's 2x. There's where my mistake was. Guess we have to be careful to enter the correct equation. All right. Now we're going to hit graph, and it should show up. Yes, it did. All right, so life is good again. All right. We're going to draw a picture of our sketch, and what we have is we went to 30,000, 40,000 I mean, there's 10, there's 20, there's 30, there's 40,000, so I'm just going to write 40K. Okay, and on our x-axis, we're going to go 50, 100, 150, 200, 250, 300, and our graph, if we would have looked at it closer, I'll show you what it looks like. I'll leave it there. We went up to just above 30,000, and we went over to the 250. So I'm going to draw my graph, and it's going to be a beautiful graph there, and it goes down to the 250. All right, we need to put down our, write down all of our information. We have 40K, 30K, 20K, so on and so forth. And on our x-axis, we had 50, 100, 150, 253, 350, 300. Let's see, there's 100, 200, 300. Yes, this was at 250. Okay. We need to write down what this is. This is feet of fence, and this is area in feet squared. All right. Now that we have our equation, we entered it in. We're going to determine what the domain of our function. Well, that hasn't changed. We still have from 0 to 250. Okay. That did not change on the x-axis. The y-axis is the one that changed. So we have to figure out what our vertex is. So to do that, we're going to go into second trace. We want to know the maximum, so we're choosing option 4. We're going to move our cursor to the left of the max, and we're going to move it over to the right of the max and hit enter, and then we're going to guess, and it tells us that it's 124.99999, which is 125, and then for our y value, it is 31,250. So I'm going to go ahead and write all that down. We have our maximum value, which is our vertex, was 125 feet, and our area that we can enclose, which is the maximum, or the vertex, is 31,250 feet. Okay. And our y-intercept, once again, is still 0, 0. x-intercept is 0, 0. We have one place. And where our second x-intercept is at 250 and 0. All right. All right, there we go. Our range, we had to find our vertex, and the range is 0 and 31,250, 31,250. We're using square brackets because those are included. All right, so we have all the information we needed, and it simply says, what is the maximum area that can be enclosed? We found that by finding the vertex of the parabola, and once again, that is 31,250. Okay. Okay, the third type of problems that we're going to be dealing with are maximum and minimum problems. Maximum revenue is basically where you're trying to make the most money, and minimum cost is keeping your operating costs low. So when we're dealing with I can't get that guy to drag over there. Whoops, that wasn't good. All right. Basically what we have is you're trying to make the most, so you're going to be looking at a parabola, and where your maximum profit, where you're making the most, that's going to be a maximum value, so you're looking for the vertex of the parabola. And when you're trying to keep the cost low, it's going to be an upward pointing parabola. So therefore, we're looking for the vertex of that, and it is at a minimum. All right. The first problem, or third problem, says find the number of units sold that produces a maximum revenue where 900x minus 0.1x squared. R is the total revenue in dollars, and X is the number of units or widgets that you have sold. We're going to go through the same process. We have to enter the equation in our calculator, figure out what our window is, and then determine the widgets or the number of units. So, all right, taking out our calculator, we're going to go ahead and turn it on. We're going to reset the memory, so we're going to do second plus 7, 1, 2. Calculator is now reset. We're going to enter our equation that's given, and it is given as 900x minus 0.1x squared. 0.1x squared. Alright, we're going to go ahead and graph it. And when we graph, we end up with nothing. So the reason being is we haven't set our window. I'm going to go ahead and tell you what our values are. For our x min, we're going to enter 0. And for our x max, we're going to enter 10,000. This is the part where you guys are going to have to just sit here and play with numbers until you figure out what the minimum and the maximum are. We're going to go to 1,000. All right. And after we've done that, we are going to hit y. We're going to change our y values. And once again, our y is equal to 0. And our maximum y is a very large number, which is 2,500,000. So what we're going to use for our scale is, what do y'all want the scale to be? We'll go with millions. Or how about let's go with 500,000. There we go. 1, 2, 500,000. And we're going to graph it. And hopefully the parabola showed up, and it did. It showed up perfect in the window. So I didn't write down our numbers. We should have written down that we went to 0. So writing down the function, we end up getting r is equal to 900x minus 0.1 x squared. Now what we need to do is we're going to go into our calculator. Turn it back. Now that our calculator is on, we're going to figure out our maximum value, which is at the vertex. The way we do that is we go to second trace, calculate our maximum. All right, we're going to go to the left bound. We're going to move over a little bit, put our cursor, hit enter. We go to the right bound. We hit enter. We hit enter one more time for our guess, and it comes up and it gives you the value of 2,025,000, and we've calculated our max revenue.